Biomarkers are any kind of compound that might be found in urine or blood that correlate with a health condition. And if you could profile these, they represent your health status. If you wanted to analyze a variety of different compounds, including biomarkers in blood, it might take days to analyze all the compounds of interest. Our method can do the analysis in just a few seconds.
It's truly song in the sense that what they're trying to do is both defend their territories and attract mates. Here is Sid in all of his glory, ruling the ladies.
Our goal when we started this work is to figure out how is the Pol gamma specifically inhibited by these drugs. With the atomic structures of a Pol gamma, we can detect the fine differences between the drug binding site in HIV, reverse transcriptase, and the human Pol gamma. And all of these informations can be used for aiding future drug design.
So we had this question, how thin superconductor can we make? So if we zoom into further, actually we can see the individual atom of the surface by using scanning tunneling microscope.
Nuclear sludge is what's left over after you try to destroy as much of the nuclear waste as you can in an existing nuclear reactor.
It's a collection of extremely recalcitrant transuranic cells, and the combination of which has very large radiotoxicity and long-term biohazard.
A single hybrid reactor can process the waste from 15 to 25 of our existing fission reactors. So you don't need a very few hybrids to get rid of the waste problem.
One major lab, which is in the United Kingdom, they already have an engineering design and they already have funding in order to put this particular magnetic geometry on their device.
At the Imaging Research Center, we do research using magnetic resonance imaging primarily to image the function and structure of the brain to try to understand both how the brain works in its normal state and how it stops working in various types of disorders, such as psychiatric or neurological disorders.
One of the really interesting things for us was starting to study 3D perception in a dynamic world.
With MRI, we can put anyone into an MRI scanner and watch their brain as they engage in mental tasks.
We actually had to build a custom apparatus so that subjects could view 3D dynamic movies while lying in an MRI scanner. One of the most surprising results that we had was really just where the hub of 3D motion processing seems to be in the brain. Our research over and over again in a series of experiments really showed that this area we'd long thought to be involved solely in two-dimensional processing was also the key player in 3D motion perception.
What we really want to do is build the center to become a resource for a broad range of research across campus. Right now the center is focused on brain research and brain imaging. What we'd like to do is expand it out so that a much broader range of researchers could get involved. In the next year and a half, we'll be moving to the Norman Hackerman building right in the middle of the UT campus. And one thing that'll do is provide us with additional space where we can add different imaging techniques that'll again let us really broaden the scope of the imaging that's going on at the UT campus.
There's been a long-standing effort over the past 30 years to control the motion of atoms in gas phase. Laser cooling has been very successful in controlling atoms and cooling them to the absolute zero. The limitation, however, of laser cooling is that it only works on about 10% of the periodic table. It cannot work on the rest. And that led me to work with my group to develop general methods that could trap and cool and control atoms and in a way that could work on any atom in the periodic table. And over the last few years, in fact, we developed such methods successfully. That work opens the door to a new field that I call atomoscience. Atomoscience is the science enabled by the control of atoms one at a time. It is a bottom-up approach and is complementary to nanoscience, which is typically a top-down approach. The goal of the Laboratory for Atomoscience is to bring together the most creative researchers in the world to develop this new field. The model for the laboratory is Tuxedo Park, founded by Alfred Loomis in the 1930s. Tuxedo Park was the starting point for many inventions, including radar and ultrasound and LORAN, which is the precursor to GPS, and really made an impact on basic science and technology. It is clear that we are at a stage today where private funding is extremely important for breakthrough research. And we need to have the flexibility of doing high risk and high payoff research, which ultimately will be very important for this country.
The Health Information Technology Certificate Program is a new program that we're launching designed to educate recent graduates of the College of Natural Science and give them the education and training they need to enter the rapidly emerging health IT workforce.
We really are in need of a skilled workforce that is able to go into a physician's office and help that physician make the transition from paper to electronic medical records.
The program will consist of a 9-week summer intensive to be held at the Clinical Education Center at Brackenridge. Students will have the opportunity to have 6 weeks of on-site training with didactic lectures, simulation in an EHR learning lab that we'll be developing there. They will then have 3 weeks practicum out in industry.
That exposure in their training phase will mean they'll have fewer surprises when they get out into the work field.
Graduates of our certificate program will be issued a university-based certificate as a health information management and exchange specialist.
These students, when they graduate, will be able to take leadership roles out in the field immediately.
We also plan to develop programs that can be delivered through an executive education model so that those around the state who may need job training or ongoing training in the case of medical professionals can take advantage of our programs and receive the highest quality education in this area.
Annual global costs for cybercrime now top the $1 trillion mark. Cybersecurity is now a national security problem. The Cybersecurity Certificate Program is really designed for working professionals in the information technology field who wish to expand their experience and their knowledge in the security arena. The Department of Homeland Security recently announced that they will be hiring up to 1,000 cybersecurity experts. We have put together a curriculum that gives working professionals the knowledge they need to kind of take the next step in their career if they're interested in specializing in information security. With that knowledge and with the certificate, we think it'll be quite advantageous to their careers.
There are lots and lots of good reasons to create targeted learning experiences that will come in an accelerated way, both within the time a student is in college, where they can, for example, earn a certificate, whether it's a certificate in statistics or computer science or health IT. And while this certainly is of value to our own students after they graduate, you can see the enormous potential it has for re-educating a workforce, for providing executive education kinds of experiences for folks. Instead of complaining about the fact that people don't know science, they don't know technology, if we actually would step up and say it's our responsibility to take the citizenry of the state of Texas and to actually educate them, to be able to have them go online and use really creative tools through Quest to get that re-education, to be able to do it in concerted ways that say, you give us 40 hours, we will give you the certificate. I think the fact that people look to UT Austin as the place that defines what that education should be in math and science is going to make a vehicle like Quest enormously important as we move forward.